and welcome to part 11 of the Mini-Mapper series. Today I'm going to talk about layout for the prototype motorboard. I'm not going to do the whole layout live or anything like that. There are people who do a better job of that on YouTube. I just got a couple of things I want to talk about. First, I want to show you a thing that I think is a useful trick in KiCad. Then I'll show you the layout of the board, and then I'm going to talk about the exciting topic of checklists. So this thing I want to show you is a way to transfer mechanical and geometrical data from your mechanical CAD program, FreeCAD basically, to KiCad. And you can use this for PCB outlines and the position of mounting holes, and in our case for aligning the photo interrupter footprint with the motor encoder disk as precisely as we can. So to do this, I've got a little demo schematic here. It's a 555 blinky, here's your 555, here's an LED, here's a battery, there's some passives. I've included some mounting holes in the schematic. Now you can put mounting holes directly on your PCB just by dropping the footprints on there when you're doing layout, but it's generally better to include a representation of these things on the schematic as well, so that when you update your net list, you don't lose those things from your layout. I think you can lock them, but if you forget to do that, they'll disappear when you update the net list. If you put them on the schematic, that doesn't happen. So everything on here has footprints assigned to it, and we're going to lay it out using a board outline derived from some CAD data. So let's go to a mechanical CAD program. Here's FreeCAD. So I've created a sketch for the board outline here. I've done it in the simplest possible way, just creating a bare sketch not associated with any other geometry. In reality, you'd probably do this by making a sketch based on other geometry. So if you've got a three-dimensional model of an enclosure, then you'd derive some geometry that gives you the board outline based on the shape of the enclosure and the positions of the mounting holes and so on. But in this case, I wanted to do a simple demo, so I just drew a sketch directly. So we've got a square board with rounded corners, and these four circles are supposed to represent mounting holes. And we want to take this outline in exactly, geometrically exactly, into KiCad, and we want to line up our mounting hole footprints exactly with these holes. So what we do is we select the sketch, we choose export, and we're going to export this as a DXF file. So we'll just call it outline.dxf. Now, to make FreeCAD export or enable FreeCAD to export DXF files, you need to install some add-on stuff. I'm not going to talk about that now. You can find out how to do it online. So we do this, does the export, and then we go to KiCad. We've got a schematic, but we're going to make a layout. We'll make a new layout. There's nothing on here. We'll import the net list. And so we've got our components. Let's move them into the middle a little bit more. There we go. And we've got a battery, got the mounting holes here. We don't have a board outline yet, so that's what we're going to do now. And to do this, you choose import graphics, and we'll go to home directory, and we'll choose outline.dxf. We're going to have interactive placement. We're going to put it on the f.fab layer, so this is for fabrication stuff. We click this, and we can place it. So we've got this geometry on this fabrication layer, and we want to move the outline onto the edge cuts layer to give us the board outline. So we just drag and select each line of this at a time. We choose properties, so I'll just use the E shortcut for the rest of them in a minute, and then we choose the edge cuts layer, and it's transferred it. Now, unfortunately, in KiCad 5, which is what I'm using here, you need to do all of these individually, so there isn't a properties for a multiple selection. I believe that KiCad 6 is going to change that, so that in KiCad 6 you ought to be able to just select all of these things in one go, all of these line segments and curves in one go, and move them all to the edge cuts layer in one action. But in KiCad 5 you can't do that, so it's a tiny bit annoying because you have to go through and select all of these things one after another, move them all individually to the edge cuts layer. But to be honest, this isn't something you do very often, so it's only a minor annoyance. And one last one, as we've got a board outline, we've moved all of the outline to the edge cuts layer, and we'll see in a minute that we'll look at it in the 3D viewer and it actually produces the right thing. The next thing is we want to put these mounting holes exactly on top of these circles. So let's just move them approximately to where they need to be, and I'll show you the nice way to do this. So what we do is we select one of these things. Oops, there it is, selected. We say position relative to, and then we say select item, and then we click on one of these circles. You see it says PCB graphic circle. We make sure the offsets are 0. We click OK, and then that mounting hole is aligned exactly with that geometry. And so before I figured out how to do this, I did a lot of moving things 0.05 of a millimeter at a time, and trying to do these things by eye. But yeah, it doesn't always pick it up. There we go. And that's obviously not very acceptable. But this approach, where you select exactly the geometry that you've made in your mechanical CAD program to align the mounting holes to, is pretty cool, I think. So let's just quickly slap all the components on without any real care. So we can look at it in the 3D viewers. Let's just move everything on there willy-nilly. And then we go into the 3D viewer. And you see that the board outline is there and the holes are there, and it's all nice. And so I really like this approach of bringing the mechanical CAD data directly into KiCad for doing the board layout. And so if I close this now, we'll get rid of the changes because I don't really care. And I go to my motorboard project, and we can quickly have a look at the layout for this thing. And just to remind you, the schematic. So we had the motor driver, motor encoder. There's a bit of power connections to the Nucleo board, and here's the layout. And there's not a whole lot to say about it. It's a relatively simple board. If we look at it in the 3D viewer, then the important things you can see are the photo interrupters on the bottom here. So the motor encoder disk will go in the slot there, and the position of this is very carefully aligned with the mounting holes. We've got 4 mounting holes, so this will give you pretty good registration. We've got the motor outputs, the connection to the Nucleo board, everything's nicely labeled. Here's the motor driver, big fat traces going to the relatively high current motor connections. We've got the motor coil current sensing here, and we've got the photo encoder as a comparator, and some passives to go with it. And then we've got the power conversion. So this boxy thing is a barrel jack to connect a 5 volt supply to, and this is an LDO that gives you the 4.5 volts. Apart from that, there's just a couple of test points. One for monitoring the voltage from the photo transistor in the photo interrupter, and one for monitoring the motor control voltage. So it's not very complicated, and I've ordered the parts from Mauser. I've sent the boards off to Eisler, and in a week or so I should be able to put it together and start doing some experiments. One last thing I want to say about this, though, is that, you know, there's a point you reach when you're doing layout when you think, I'm nearly finished. just 10 minutes, 15 minutes, half an hour more, and I'll be able to send it off for fabrication. Before you do that, I would strongly recommend that you, where have we gone? You run through a checklist. And I only started doing this on this project, and it was useful. I found a couple of problems. And I started off with this checklist from Andrew Zonenberg. I can't remember how I came across it. Someone was asking about the PCB checklists on Twitter or the Contextual Electronics Forum. I can't remember where. And someone pointed out this one. So, for instance, on the schematic checklist, there's all the kind of things you'd expect, like making sure your ERC is good, making sure you got the pin numbers right, the packages are right, the thermal pads are connected to the correct power rail. And Andrew said when he posted this that virtually every point on it is derived from a mistake he's made in the past. So these things are a great way to learn from other people's mistakes and try not to make the same mistakes yourself. And Andrew's checklist is fairly comprehensive. I mean, you see there's quite a lot of stuff in there. Some of the stuff in there I didn't quite even understand, and some of it is specific to like microcontrollers. There's some FPGA specific stuff in there. So not everything is relevant to every project. So there's one for schematics and then there's one for layout. And basically, what I did is I worked through both of these from beginning to end. Well, from beginning to end, going over a few times because I skipped some things and came back to them because they were more difficult. And it definitely improves quality. And I mean, checklists are used pretty widely in aviation and medicine now, and they really are a very good way of avoiding making silly mistakes. And I don't know about you, but I have a lot of capacity for making silly mistakes when I'm learning something as complicated as electronics, schematic capture, and PCB layout. So one other thing I'll tell you about is Eisler. So if you live in the US, the natural place to send your boards for this kind of hobbyist stuff is Oshpark. They make nice purple PCBs and they come back in a few days. If you live in Europe, particularly over the last few months with the disruption to international supply that's been going on, boards from Oshpark take a long time to arrive. So instead you can go to Eisler, and they make great boards, and they have very straightforward and pretty cheap pricing. So these were 3 for 19 euros. This is a little bit slow because I'm in the shed, and the internet connection isn't great. But they, no, the internet connection is really not great. Let's see if we can see it in the viewer. Yeah, so they've got a nice board viewer as well, and they make a point of saying that if you order boards from them and in any way it doesn't match up with what's on their board viewer, you get a free respin. So that's a pretty good good situation, I think. And they also have a I'm not gonna go to it now, but they have a thing where you can order with simple and slack design rules very quickly, or you can wait a few more days and you get nicer design rules. And if you end up having things that have plated slots like this, you need to use their higher quality service. But I think it's only 5 working days, so it's not really a bother. So they really are kind of the Oshpark of Europe, I think. So that's about it for the layout. And so the next thing we're going to do is I'm going to try and make these motor encoder discs. And I'm not going to film that because it'll mostly be me looking through a magnifying glass at tiny pieces of plastic, probably swearing quite a lot. So I'll just take some photos and make a little kind of photo essay of doing that. And then the next thing is to do some very simple software experiments with the Nucleo board that I'm going to use for talking to these things. So I'll do those things in the next couple of days. And then while we're waiting for these boards and components to arrive, I'm going to start thinking about the next sub-project. which is, I think, possibly one of the most fun bits of this. So we'll get to that soon. See you next time.